In this topic, we are now going to proceed and check out what are variables and data types in Java. Let us first consider an example of our country, India. So our name of the country is India, its GDP is $2.454 trillion, its population is 132 crores, population density is 393.0% per square kilometer, it is a secular state and the symbol of its currency is rupees that you can see here. Now if I ask you to represent all these stats with the help of Java language, so for that what you can do? Because this language is only understandable by us, not by Java. So inside our Java application, let us remove all these old codes. And now let us write all the data in our own language first. So name of the country is India. Its population is 132 crore 65 lakhs and 72,000. Population density is 393.0 per square kilometer. GDP is this much. Currency symbol is rupees and it is a secular state. Now the Java does not understand what we have actually written inside the main method. So for that we have to make Java understand that the name of the country is India in its own language. So for that in Java we have something called variables and data types. So this name can be converted to a variable and its data type can be the string. So any text in Java can be represented with the help of a string. So let us type capital STRING space name and instead of is let us use equal to. And now whatever text that we write in Java we have to enclose it within the double quote. So let us put double quote open and close and end the statement with the help of a semicolon. So string name equal to India, that states that India is a text of the type string which is represented with the help of the variable name of name. And now here for population you can notice it is actually a number. Now a number in Java can be represented with the help of int data type space population equal to this much and end the statement with the help of a semicolon. Now again here it shows some error, it is not a statement. Now in Java there is no meaning of using comma in between a number. So in Java this comma does not work. So let us remove all these comma and now we are good to go. So the population of our country is this much. And now just below it if you notice here we have a decimal value. Population density is 393.0 per square kilometer. Now earlier we had a number, so we used int. And here we have a decimal value, or in short it is a floating point value. So in Java we represent such number with the help of float space population density. Now here if you notice I am using population and soon after that we don't have any space. So also remember that whenever you define a data type followed by the variable name, you have to make sure the name is a single word. So for that I am using the convention as population followed by capital D so that it is now readable in nature, population density, and replace is by equal to. And then after 393.0 put a semicolon. Now per square kilometer does not make sense in Java. So here let us remove it. And here again it is showing some error. Now whenever we use the floating point value, we need to end the value with the help of small f or capital F as per your wish. I am using a small f here. So always remember whenever we use a floating point value, always end it with the help of small f. And now below it we again have a decimal number. Now this time I am going to represent it with the help of a double space GDP equal to this much value. End it with a semicolon and let us remove the text. Now in case of double, here at the end we need to write D, and even if you remove it then by default this GDP will be double in nature as compared to float where we need to write F explicitly, but in double we don't have to write any suffix. Now you must be thinking why here I have taken float and why here I have taken double, as both are decimal numbers. Now the reason behind this is that the capacity of the floating point value to store number is less compared to double. So a double can store a larger decimal number compared to the float data type. And if I am going to expand the GDP of the country, then it may be a very large number. So to store a very large decimal point number, we use double, and to store a very short decimal number, we use float. Now here just below I have currency symbol of our country. Now here the currency is rupee, and this symbol of rupee may not be available in your keyboard. So at present let us replace it by R, and just before currency let us use the keyword of char space currency equal to, let's say, R. Now this data type of character can only store a single digit or a text or a character. So here we need to use a single quote and close it with the help of single quote as well. Now notice here, in case of string we have a double quote, but in character we just have a single quote, open and close. Now here you cannot type multiple characters such as rupees or something like that, or a multiple number. You just can type a single digit or a single text character. So here I am simply using R. Now if you want to represent the currency of India, which is represented by this symbol, then you can simply copy it somewhere from the Google and can paste it here like this. But if you are unable to get this symbol from the Google, then instead of this symbol you can type backslash followed by U then 20B9. Paste it here and remove one more backslash. Now you must be wondering, just now I told you within the single quote I can only have one value, but here I am having the multiple value. So let me tell you one thing, whenever you see backslash followed by U followed by some hex value, then it is basically a single character, which in our case altogether representing the symbol of rupee. So both ways it is going to work. Now at the bottom we have is secular state. So for this let us define the data type as Boolean space and again. Now proceeding forward, if I ask you to print a statement, let us say India has a population of 132 crores 65 lakh and 72,000. So in order to print out this statement using the code that we have written here, let us write our print statement. So let us write system.out.print. Now within the brackets, instead of writing India, let us use this variable as name. Let us now run the code. So in the output we have India. Now as per our objective, we have to append has population of this much again. So what we can do, after name let us put the plus sign. If you want you can give a space here and then use the double quote, and within the double quote give it a space. Let us copy the code from here, has population of, and again give a space within the double quote. Let us now run the code. So here we got India has a population of. So what the compiler has done, it has simply interpreted name as India and then appended this string has population of. And then at the end I want to append this value, which is actually present within the population variable. Let us use after the quote plus sign and then use population variable. Let us now run the code. So here we get India has population of this much value. So now you can notice how we have simply used the variable name with the help of plus symbol and then the text or a string and then again the population, which is replaced by its value in the output console here. And now if I append some text here inside the comment and ask you to print this statement as well and the population density of this much person per square kilometer, So for that, let us copy the text till here, and then after population let us use plus double quote open and close, and within the double quote let us paste it, and make sure before and give it a space, and after of let us use this value which is stored inside the population density. Let us use population density, and then again use the plus symbol, double quote open and close, and within the double quote let us paste this text. And now let us run the code. So here we get India has population of this much and population density of 393.0 person per square kilometer. So in this way you can then print out the GDP, currency, and also if it is a secular state or not, like this, inside the system.out.print statement. So in the previous two videos, we represented all these statistics in the Java language. Now the question arises, what is a variable and what is a data type? Let us consider this statement, integer population equal to this much value. Now this int is basically the data type. This population is the variable name, and after the equal to sign we have the value. And let us take another example of Boolean is secular equal to true. So again, Boolean is the data type, is secular is the variable name, and then we have the value. And also note that whatever variable name that we have here should be a single word. It should not be splitted into two words. So that is why I am using the variable name as is and without space secular. And to make it readable, I am using S as capital. And now one more thing that I want to talk to you about is that let us consider this statement, Boolean is secular equal to true. Now at the time of declaring this data type and also the variable name, you are not sure that India is secular state or not. That is, currently you don't know it is a secular state or not. And later on, after writing some code, you realize that India is a secular state. So in that case you can make is secular equal to true. So there is no harm in initializing a variable name later on within your main method. So for rest of the variables and data types, you can do the same thing. You can declare the population and later on you can decide the value that you want to store within this population variable. So till now we learnt about the data type of Boolean, char, int, float, and double. Apart from all these data types, we have few more data types such as byte, short, and long. Now whenever we run our code, these data types consume some memory in order to store the values. So in the runtime, the float and double takes the size of 4 byte and 8 byte respectively. Let us represent the float and double with the help of small glass and little larger glass. Just because double is of 8 byte, it can store a very large decimal value or the floating point value. Now similarly, long has 8 byte, int has 4 byte, short has 2 byte, byte takes 1 byte, char takes 2 byte, and boolean takes 1 bit. And 1 byte is equivalent to 8 bits. So a boolean takes 1 by 8 times of 1 byte. And now you must have noticed the float and double, I have represented it with the help of a purple glass. And here at the center I have some other color glass, and here again I have some other color glasses. Now the reason behind this is that the float and double can store the floating point data types, as for example 2.5f, 3.89d, and so on. So these data types can store the decimal numbers. Now at the center I have byte, short, int, and long, and all these data types are capable to store the integer data type, such as the numbers that does not contain a decimal number. And then we have the char that can store a single character, may it be a number, a alphabet, and a special symbols. And this Boolean can either store true or false, that is the Boolean data type. Now all these data types altogether are known as primitive data types in Java. Now after we have checked the data types and variables in Java, let us now check out the type conversions. Now what are type conversions? These are basically of the type of explicit and implicit conversions. So one by one let us check it out. So here let us consider a double variable. Now suppose we have one more integer variable. According to the size of these two variables, the double due to its size can easily accommodate the integer variable inside it. So this type of conversion, that is converting the smaller data type into the larger data type, is known as the implicit conversion. Because the compiler never complains when we have such type of conversion. But now, suppose we have a smaller integer data type and we have the double variable. Now as per the size, when we try to accommodate the double into the int, then the compiler simply complains that hey, you cannot do it easily. Because the integer is of smaller size compared to the double. So how can it easily accommodate the double into it? So for that we have to explicitly tell the compiler that I am going to do such conversion, be ready to accept it. But in case of explicit conversion, what happens is that when we try to accommodate double into the int, then we lose some data due to its size. Because the double is of greater size, so when we try to accommodate double into the int, so we definitely lose some data. Let's check it out inside the IntelliJ IDE. So here inside the IntelliJ IDE, let us first check out the implicit conversion. So for that, suppose I have int radius equal to, let us assume, 400 units. And then suppose I have double new radius equal to again 400. Now here, since I'm using 400, which is equal to the value that I have assigned here, so instead of using the 400, why don't we assign radius here? In the runtime, what compiler will do, it will simply assign the value of radius, that is 400, into the variable of new radius. So the new radius variable will now bear the value of 400. Now if I try to print out the value of new radius, then let's see what we actually get. If you notice in the output console, we have 400.0. Now on the right hand side, I am having the integer value of radius. And on the left hand side, I am having a double variable. So in the runtime, what happens is that this 400 gets converted into the double. Now the double contains the floating point value, that is the decimal number. So the 400 gets converted into 400.0, which is in the form of decimal. So this is known as the implicit conversion. Now let us take another example. Now this time let us use double space diameter equal to 3.78, and then let us use int new diameter equal to, let's say, diameter. Now the value of diameter is actually 3.78. So as per the rule, we cannot store the 3.78, that is a decimal number, into the integer variable. So for that in Java, we need to tell the compiler that we are going to convert this value into the integer value. Now instead of 3.78, let us again write diameter, and let us explicitly tell the compiler to convert it into the int value. And now, so in the runtime, this diameter will be converted into the integer and then will be stored into this variable of new diameter. Now, if I try to print out, let's say, new diameter, And let us run the code. So here you can notice we have 3 in the output. Now this 403 is getting appended, so let us use here print line method. Let us now run the code again so as to get the cleaner output. And there we go, we got 3 as a new diameter. Now originally our diameter was 3.78. So as soon as we convert the diameter into the integer value, so we have just lost 0.78. That is whatever value that we have after the decimal point, we are simply losing it. So that is why we get 3 here. So always remember, in case of explicit conversion, you may lose some value. Now let us take some other example. Instead of double, let us use long. So long diameter, let us use a very long integer value, let's say 7878 and so on. So here I have a 10-digit number. And if you hover over it, the compiler is not happy that it is not an integer number because it is too large. So here you have to tell the compiler that this number is basically of the type of long. So at the end, let us use capital L. So always remember, for the long we have to use capital L at the end, similar to float where we used capital F or small f at the end. And now here if I use diameter and cast it to the integer and print out the value of new diameter here, let us see what is the output. And there we go, we have some weird output. Just because we are losing some value while we are explicitly converting the diameter into the integer value. And now in case of implicit conversion, instead of double, let us use long. And try to run the code. So here in the output we have 400. It has made no difference in the output just because on the right hand side I have 400, which is basically the integer value. So in the runtime, this integer is getting converted into the long. So we got no difference in the output because both long and int does not contain any decimal point value. So this was all about the implicit and explicit conversion for the primitive data type. Let us now summarize our topic of data types and variables in Java. So in this topic, we learned about various data types, among which the first is the integer types. So in case of integer types, we checked out the byte, short, int, and also the long. Now these are all the size of these data types in bits. Now make a note, 8 bits equal to 1 byte. So here I have simply represented the size of the data type with the help of bits. And here I have two columns at the center, the minimum value that this data type can bear and also the maximum value that this data type can have. And on the right hand side, I have the literal format that shows that in case of long, we have to append capital L at the end. And for the rest of the integer types, it don't require any suffix. It is only in the case of long that we need to append capital L at the end. Now these are some examples of these data types, such as byte, short, int, and long. They all are basically number representation. Now proceeding forward, we saw the floating types, such as the float and double data type, and these are the size in bits. And here we have the smallest value that it can have and also the largest possible value that it can have. Now for the literal format, if you notice, in case of float, we need to have small f appended at the end. But in case of double, the suffix d is basically optional. If you want, you can have it, or if you don't want, then you don't need to have it. Now these are some examples in front of you. So here the float contains f at the end, and in case of double, if you want, you can also remove this d. It will then work fine as well. And now at the end we have the Boolean and character data type. So for the Boolean, the size it takes is basically 1 bit. And as for example, the Boolean variable can only contain the values of true and false. Then comes the character data type, whose size is 16 bits, that is equivalent to 2 bytes. And in case of character, we have such examples. And in each of the example, if you notice, we have a single character within the single quote, such as $, alphabet A, number 3, and here at the end I have some Unicode character. Now whenever you notice backslash followed by U and then some value which is basically the hex value, then always remember these basically represent one character. Like in our case, this bunch of value represent the rupee symbol. So this was all about the data type and variable in case of Java. Now coming up next, we are going to check out how can we take user input and store those values inside the variables and use it as per our requirement. Again, the name should be one word, and here what I will do, instead of state I will use equal to, let's say, true. So this Boolean data type can only contain the value of either true or false, like this. Fine, since India is a secular state, so let us use true. So this is how we use the variables and data types in Java to make Java understand in its own language.